heating, cooling, shaping, refining, working the metal to make it stronger, to make it last longer, striking the metal repeatedly and methodically over and over, transforming the metal into a hardened, resilient part. The proven metalworking process of blacksmithing has been around for hundreds of years, a process developed in the past, linking us to the present. Today's shot peening process is also metalworking, of a different type, but still proven and reliable. To better understand shot peening, imagine blasting the surface of a material with a shotgun. Imagine dozens of shot pellets in a tightly packed group, simultaneously striking the surface, blasting one side, then the other, then another, covering the entire surface. Now imagine one continuous barrage of thousands of pellets blasting the material. Imagine shot peening. Originally developed for use in the automotive industry, shot peening is a proven technique for making metal parts last longer. It has been used for more than 50 years to extend metal component lifespans. Now used in the aircraft industry, shot peening has enabled aircraft components to withstand the increased stress and loads demanded of them. And this has, in turn, yielded increased durability. Yet, just as today's aircraft components must undergo continual improvement, today's methods and the technologies used to achieve those improvements must also be continually improved. Recognizing the need for highly controlled, cost-effective shot peening technology, the Air Force and Pratt Whitney, in a unique teaming arrangement with USBI and Progressive Blasting Systems, has developed an automated work center for shot peening aircraft engine components. This new automated process now provides the Air Force Depot a thorough, consistent, and safe means to extend the service life of aircraft engine components. This program is the result of an earlier initiative of the Air Force Manufacturing Technologies Directorate, which identified areas within the air logistics centers requiring process improvements, specifically in automation and robotics. A natural follow-up to this initiative was an in-depth study of the existing shot peening operation at the San Antonio Air Logistics Center, with benefits ultimately to be realized in increased production and decreased environmental impacts. Non-automated shot peening practices utilize a proven approach. However, they are extremely labor-intensive and time-consuming. These practices involve a manual, painstaking approach, utilizing adhesive tape, dowel rods, protractors, and a great deal of manual dexterity. The adhesive tape is used to mask parts, leaving only those areas to be peened exposed. Hoists are used to load individual parts into the work cells. Extensive measurements on a trial-and-error basis are made to position the blast nozzles, accurately aiming each blast nozzle at precise angles and distances for each component, securing each nozzle by a complex arrangement of fixtures, nuts, and bolts, loading machines with the specified media, and operating machines which require a certain feel on the part of the operator for proper results. During operation, the technician must provide constant monitoring and control of the machines, determine when the process is complete, and stop the process at the appropriate time. Then, if a different surface area on the part, or if a different part is to be peened, the entire setup must be torn down and a completely new setup created. And in the event of a system malfunction, for example a broken drive belt on a turntable, failing to stop the process could easily ruin a part. Further complicating the situation, the entire process takes place in a deafening environment. This time-consuming process must be done for each part, each time, with consistent levels of quality being difficult to obtain, Definitely not advantageous to throughput of very small numbers of a given part number, and certainly not an efficient process by any means. Typically, machine setup time for a given part number can be more than 2 hours, with setup highly dependent upon the skill and availability of an operator. This, coupled with the fact that an operator's health and safety are at risk, calls for process improvements. The current shot peening modernization effort, provided by Pratt Whitney, USBI, and Progressive Blasting Systems, consists of a fully automated, closed-loop, controlled shot peening cell integrated by a supervisory computer system. First, it provides such technological enhancements as robotic manipulation, computer numerics control, multitask monitoring, and a closed-loop system, yielding military specification accuracy and repeatability. Second, it provides procedural enhancements, such as improved part preparation and handling through powered roller conveyors and automatic loading, the addition of advanced holding and masking fixtures for greater accuracy, durability, and reduction in setup time, controlled media shot size, velocity, and flow, controlled air pressure, control of nozzle to work surface distance and angle of impingement, and dual media availability with quick changeout capability and automatic replenishment. Third, it provides environmental enhancements, such as redesigned cell construction and reduced hands-on hardware manipulation, which improve health and safety benefits, media waste reduction, and noise abatement features. Fourth, it provides economical benefits such as reduced operating expenses and lower cost per part repaired. In order to introduce automation into the shot peening process, certain critical variables must be maintained. This involves the utilization of sensors under computer numerically controlled, or CNC, direction. The critical variables to be controlled are media velocity, media flow, air pressure, nozzle to work surface distance, and angle of impingement. Incorporated into the automated shot peening cell are two 4-axis independently controlled robots. The control system utilizes coordinated feedback to instruct the robots and prevent their crashing into each other. It also enables alternating control of the turntable during the blast cycle. The shot peening process for that part can be simply performed over and over by just rerunning the part program or downloading it from the supervisory control system. In the conventional setup, the machine duration time is determined by the area which is most difficult to peen, a situation which is untrue with the robotic approach. In addition, the automated system not only provides 85% reduction in setup time, but more production per hour in operation. The result? A 3-fold production rate increase. No less than once every second, the computer compares each processing parameter to preset maximum and minimum limits. The computer then stores this data for machine control and historical trending. And with the introduction of highly controlled, state-of-the-art machines, reduced time, increased accuracy, and greater adaptability to a mixed and growing workload is assured. The supervisory control stores the individual part programs. It also provides tracking and storage of serialized part processing parameters, system history and management reports, process trending, and qualitative data, resulting in repeatability, quality, and cell efficiency. Designed to minimize the process noise, the blast cabinet is constructed from 1/2-inch rolled steel plate, coated with 1/2-inch polyurethane. This design ensures quiet operation. The total area measures 120 inches by 96 inches and will accommodate the largest of engine parts anticipated at the San Antonio Air Logistics Center. Advantages gained from this modernization project include lowered machine maintenance, increased maintainability and supportability, instant reaction time to changing shop air pressure, consistent and variable media flow rates, a minimum amount of effort to change or add media, simplified computer-assisted operation and troubleshooting, and significant operator and environmental safety improvements. In designing the system, a team effort was utilized, drawing upon the individual strengths of each member. Under the leadership of the Air Force Program Manager, Pratt Whitney spearheaded the effort, utilizing experiences gained from its technological base, manufacturing facilities, and knowledge of the aerospace industry. USBI applied its vast experience in controls and system integration technology. USBI has developed support systems that manage 35,000 components in the shuttle rocket booster assembly and refurbishment cycle. Progressive Blasting Systems began designing and building automated pneumatic equipment in 1968 and has since become a leader in precision shot peen work cells. The strategic application of robotics and system integration was critical to the successful automation of the shot peen work cell. Implementation of this automated work cell increases productivity and reproducibility, improves quality, and enhances operator safety. At the same time, this system establishes a system-oriented process that is reliable, supportable, and maintainable. Metalworking has come a long way since the days of the local blacksmith. Things change, expectations change. Materials and processes are not what they once were. New materials are constantly being developed, and new processes and techniques to handle these materials have to be constantly developed to meet the challenge. Automated shot peening is now one of those new processes.